Okay, welcome back. So now this sheet is meant to actually just talk about all of the different ways that we can graph and have most of it all on one sheet. So basically to graph any line, you need only 2 points. Like if you're given just 2 points, you just graph those 2 ordered pairs and you draw a line. Or you can be given 1 point and the slope. And the slope is going to help you find more points. So let's go ahead and do a couple of these together. So the first one, I just want to graph a line that goes through these 2 ordered pairs. Now, don't forget, ordered pairs go x and then y, and remember that x is right and left and y is up and down. Now that we've graphed some things with slope, it sometimes is a little confusing. So I'm going to start with finding the ordered pair 3, -5, which means I go to the right 3, down 5, so you should be doing the same. So there's the ordered pair 3, -5, and then -4, 2 is to the left 4 and up 2. And so there's that ordered pair right there. And so now use a straight edge or a ruler or something to draw a straight line. Mine is going to be a little bit tricky because I am doing this on an iPad, but you guys on your paper can do that. And so there you go. You've got a straight line. Make sure your line has arrows at the bottom. So now the next one is just saying graph a line that has a slope of 1/2 and goes through 2, 1. So this is just, we know it has to go through the ordered pair 2, 1, so I need to find the ordered pair 2, 1. Remember, it goes x and then y, so I go to the right 2, up 1. And now from there, my slope of 1/2, remember 1/2, it's rise over run. So from that point, I'm going to rise 1, run 2. So from there, I'm either going to go up 1 to the right 2 and put a point there, up 1 to the right 2, put a point there. And then remember that the unsimplified version of positive 1/2 could be -1 over -2, right? That can be written, that's the unsimplified form, which means I'm going down 1 to the left 2. So let's go ahead and finish that. I'm going to go up 1 to the right 2, put some points there, down 1 to the left 2, down 1 to the left 2, and then I've got all these ordered pairs along here. And so there's all of the possible ordered pairs here. Now number 3 says graph the line that has a slope of -2/3 that goes through -4, -3. So I'm going to start again at -4, -3. That's x and then y, so I go -4 is to the left 4 and then down 3. And so there's -4, -3. And now when I'm graphing the slope of -2/3, that can be written as -2 over +3, or the unsimplified version would be +2 over -3. So just think about what that means. So if I am going -2/3, that means I'm going down 2 to the right 3, and then the opposite of that would be 2 over -3, which would be up 2 to the left 3. So just remember that slope is rise over run, or our change in y over our change in x. So graphing slope is the exact opposite as graphing ordered pairs. Okay? So now number 4 is saying graph the line that has a slope of 5 that goes through 0, 4. And remember 5 can be written as 5 over 1, or the unsimplified version would be -5 over -1. So I'm going to start at 0, 4, so I'm going to go up 4, 1, 2, 3, 4, and I'm going down 5, 1, I'm sorry, I would like to go up 5 and to the right 1, and I can't go up 5 and to the right 1, so I have to do the opposite of that, which is down 5 to the left 1, and then I can do it one more time. 1, 2, 3, 4, 5 to the left 1. And then we have this very steep positive line. All right, now stop the video right now and try 5 and 6 on your own and tune back in to see that you've got it right. And there are your answers for 5 and 6. Over to the right, I wrote the different ways we could write the slope. So let's move on to the next section. So this section right here is just reminding you, if you have an equation in slope-intercept form, you're given the slope and the y-intercept, so go ahead and graph it using the slope and the y-intercept. I'll do the first one with you. So the slope is the coefficient of x whenever you have slope-intercept form, so here my slope is 1/4. My y-intercept is the ordered pair 0, 3. You could just write 3 there if you wanted to. And so I'm going to start here at 0, 3. That's where you start, and then you rise 1, run 4. So that's up 1 to the right 4. And then the exact opposite of up and to the right is down and to the left. And remember that positive slopes, if we're reading from left to right, positive slopes appear to be going up. Negative slopes appear to be going down. Stop the video, try 8 and 9, and tune back in to make sure you're correct. And here is what those two lines should look like. Again, quick reminder, this one had a positive slope. So if I'm reading from left to right, it goes up. These two have negative slopes, and so negative slopes, if you're reading from left to right, go down, right? They start high and they go low. So that's helpful to remember when you step back and look at your line, make sure it's going in the right direction. Let's move on to the next section. So if we don't have a line in slope-intercept form, maybe it's in point-slope form. So reminder of point-slope form that it's y minus y1 equals the slope, and then you have in parentheses x minus x1. Just a reminder, because it's subtraction, when you're pulling out your ordered pair, you're pulling out the opposite of the term that you see here. So for, again, an example, for this equation, y minus 6 equals 5, and then x minus 2, the slope here is what's in front of the parentheses, which is 5. The point is not negative 2, negative 6, but positive 2, positive 6. And now let's take a look at the next one. Number 11, the slope is right in front of the parenthesis, which is 1/2. And the point is not negative 4, positive 2, but positive 4, negative 2. All right, now take a moment to stop the video and finish this little section, and then tune back in to make sure you're right. All right, and so here are the answers to these three. If you don't get them, stop the video, come let me know. So now we could have horizontal and vertical lines. So remember, if you only have an x, that represents a vertical line with an undefined slope. And if you only have a y, that represents a horizontal line. So if you're missing one of the variables, then you actually have to remember, well, which one is that, x or y? Okay, so number 13, graph y equals negative 4. Well, that means that all of my y values are negative 4. That's a horizontal line. So here my slope is going to be 0, and point, you can give me any ordered pair that's going to be on that line, but I like to stick with the y-intercept. So I could say 0, negative 4. Pretty much here for point, you could give me any ordered pair where y is negative 4. So I'm going to go down to 0, negative 4, and I'm going to graph a horizontal line. Now, if you are having trouble remembering if it's horizontal or vertical, here's my suggestion. When you have the equation y equals negative 4, let's make an xy chart and let's just look at that for a second. If y is negative 4, that means every ordered pair has to have y as negative 4. This equation does not mention x at all, which basically means that x can be anything. So suppose I've got 0, 1, and 2. Let's just take a look at those ordered pairs for just a second. The ordered pair 0, negative 4, well, that's here, 0, negative 4, and you could put a dot there. The ordered pair 1, negative 4, well, that means I'm going to the right one, down 4. There's a dot there. So automatically you're like, oh, that's a horizontal line. But if you wanted to take it a step further and go 2, negative 4, you go to the right 2 and down 4, right? Every single time you have to go down 4, which is going to put all of those points in a horizontal line. Okay, so I should have circled horizontal here. Now, number 14, you may look at that and go, what? I have no idea what to do. Well, this one, you only have an x value. And right now, x isn't alone, so what we need to do is we need to solve for x here. So I'm going to add 4 to both sides. I'm going to do that up here, and then I'm going to write it off to the side. So I'm going to have 3x equals, well, 2 plus 4 is 6. And then we're going to divide by 3, and we then get the equation x is equal to 2. So what I had to do is I had to put it in a usable form. So that right there, x equals 2, because we're missing our y value, that's saying that all of the x values have to be 2. That's going to give us a vertical line. So, or I have an x-intercept of 2, right? So the slope is going to be undefined. I would like you to continue to write the word undefined. Try not to abbreviate it. I want to make sure you know that word. And then a point would be anything where the x value is 2. I like to say that it has an x-intercept of 2. So I'm going to go to the right 2. And no matter what, since x has to be 2, I'm going to have to go to the right 2 every single time, right? So if I have the ordered pair 2, 1, or 2, 2, or 2, 3, think about where all those ordered pairs are. They all stack upon each other. And so vertical lines have no slope, so we say it's undefined, and it goes through the ordered pair to 0. All right, so this next little section here is what do you do if you have an equation, it does not appear to be in slope-intercept form, it does not appear to be in point-slope form, and it doesn't just have an x or it doesn't just have a y, like what do I do? Well, typically what we do is we just convert it to slope-intercept form. We just change it, right? So slope-intercept form is y equals mx plus b. So all I have to do is move the equation around so that y is alone. So let's take a look at number 15. Number 15 says 4y equals 2x plus 8. Y is not alone, but it has a 4 in front of it. So think about what could I do to cancel out that 4? Oh, I could divide everything by 4. So now look what happens. So I divide this by 4, I divide this by 4, and I get the 4's cancel out on the left, and I'm left with y equals, now let's think about this. We are dividing both 2x and 8 by 4. So let's look. 2 over 4 reduces to 1/2, right? 2/4 is 1/2. So my coefficient of x is 1/2 x, and then 8 over 4, well, 8 divided by 4 is 2. You have to remember you're dividing both things by that. So there you go, slope-intercept form. So now I know that my slope is 1/2, and the point that it goes through is the y-intercept of 0, 2. So we start at 0, 2, we put a dot there, and we rise 1, run 2. So we go up 1 to the right 2, or we can go down 1 to the left 2. And you've got your line. Now, if you were ever unsure as to whether or not you've done this correctly, then you could pick an ordered pair on the line, like say this ordered pair right here. Let's say I picked the ordered pair 2, 3. That ordered pair, you could go back to the original equation and plug 2 in for x and 3 in for y, and you could just double check to see if it works. And so that will help you. Any of these ordered pairs, these are solutions, and these solutions will make the equation true. Let's take a look at number 16. So number 16, we need to get y alone in order for this to be in slope-intercept form. So what I'm going to do is I'm going to start by subtracting x first to get that x to the other side, and I'm going to get 3y equals 3 minus x. And then I'm going to divide everything by 3. The 3's on the left-hand side cancel out, and then I'm left with y equals, now take a look at what we have here. 3 over 3 is 1, so I've got 1. And then now if you look here, you've got a negative x. What number would go in front of that x? That would be a 1. So this has a coefficient of 1. So now don't be careful here. This would mean that my slope is negative 1/3. So I end up with negative 1/3 x. So my slope here is negative 1/3, and the point that it goes through is the ordered pair 0, 1. That's your y-intercept. All right? Now stop the video. I want you to graph this line and try number 17 on your own, and then chime back in to see if you've got it right. And here are the next two. Notice both of these have negative slopes, so they should be going down. So now you are welcome to start the homework. On the full sheet of homework, be sure to read the directions pretty clearly because I'm asking you to identify what form something is in before you start the problem. And then if it's not in a form, then you're going to need to write none, and then you go on to put it in a usable form. Okay? Good luck.